Hi and welcome to a memo discussion of evaluation 2. So I've got the memo or the question paper open here. We've got the PDF, we've got the old file and we've got the .c file. So how we will open the PDF file is we can just drag and drop it to Google Chrome and it will open. I will quickly drag and drop this template file that you received into code blocks and it's open there, and then the old file I'm going to change to .exe. It's going to ask me if you change a file name extension the file might become unusable. Are you sure? Yes, we are sure because we know it's an exe file. I'm going to quickly double click on this and it's going to open. So as you can see, this is now the showcase file that you received. So if we have the showcase file open here, so it says welcome to TUT IoT Engineering Software Design, student number, whatever, populate the following. So you don't really know what's going on in this application at the moment, but let's first close this and we will get back to this. So I'm going to open the question paper and I'm going to quickly read through it with you. So if we go down, you will see, this mouse. There's just the instructions. Let's quickly zoom out. And this mouse doesn't want to work with me today. So if we quickly scroll up, you will see here's the instructions. Plagiarism is not allowed. Upload your .c file to the dedicated MyTutor upload link. Internet protocol addresses will be saved. No USB devices or external devices are allowed. No external internet access are allowed. And this was the scope for evaluation 2, unit 1 to unit 7. Then if we go along, other instructions, write the program in C programming language using structured programming principles. The program must be edited according to all stated requirements. This is how you need to save your file. So it's your student number.c, for example, 217 blah 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 .c. So please do not add your initials, do not add evaluation 2 at the end or at the front, only your student number. And there's still students that don't read this here. So please make sure that you save your file accordingly. Okay, write your name and student number at the top of the provided template file. So that's going to be in that template file that you're going to change to your student number. Write your name. Do not modify the C library functions, names or constants provided in the template. Complete the code in the template according to the instructions given in the questions. And remember to save your work on the PC D drive. Okay, so if you quickly look, there's the D drive, you save it in there. And then if we go further, this is going to be the question. So the question is, a structured C program is required to create a TUT IoT application. IoT, the Internet of Things. The application main function will be broken into 4 steps. Step 1, or step 0, sorry, initialize an array of type IoT node that is called TUT IoT. So it says here, this step is already complete in the template and nothing have to be added here. Okay, so you're going to start at step 1. So step 1, create a dynamic array of size, node value size, provide a constant for each pointer called node value, and initialize each value of the array to 0. So that's very, very important. Use the calloc statement to create a dynamic array. Calloc, size of the array, and then size of the memory space for each element. So that's how you use the calloc statement or function. Then 2 repetition structures must be implemented in step 1. An outer repetition structure will enable the program to traverse through each element of TUT IoT array. Inside the outer repetition structure, the program will create a dynamic array and another repetition structure to initialize each element of the array to 0. Okay, use an appropriate constant to determine the number of loops needed. Okay, then if we go on to step 2, display the program header to the user and user on the command prompt interface by using the program header function. Okay, so display the program header. Read this carefully. Display the program header to the user on the command prompt interface by using the program header function. Okay, so what is the program header? So if you quickly jump back, you will see, if we go quickly to our showcase file, you will see here, this is what we would call a program header. So that's the header. This is what is asked of the user. That's the, either the user interface, select one or select two or do something here, and we will get to that in a moment. So that's the program header. Then use an appropriate repetition structure printf scanf to initialize the node name, node floor, and node ceiling values of each element of the TUT array. The getchar and system CLS function must be used to pause the program before progressing to step 3. So let's quickly see how this is going to look. So we've got our program header, and it says populate the following: node names, node floor, node ceiling, as stated in the PDF. We press any key to start. So I'm going to press enter, for instance. Oh, now this one is confused. Let's quickly just run it again. Okay, so it's going to say node name, and let's call this sensor 1, for instance. The floor value, okay, the floor value is basically, if we quickly jump here, it will say the node floor, node ceiling values of each element of the TUT array. So you don't, or you may not know exactly what's going on with this node floor, node ceiling at the moment, but if you're familiar with the technical terms in Excel, if you create, basically generate random values, and in not just in Excel, but in general, if we say floor and ceiling, floor is going to be our bottom value, our minimum value, and ceiling is going to be our maximum value. So in between node and node ceiling, we normally go and generate random values, but that's going to be stated a little bit further in this program, but we're just going to play with it for now. So let's give it a floor of 1 and a ceiling of 4. We're going to have a sensor 2, and we're going to give it a floor of 3 and a ceiling of 6. We're going to have a sensor 3, and we're going to give it a floor of 5 and a ceiling of 8. And then lastly, it's going to say press any key to continue. So as you can see, it's going to be 3 sensors that we're going to store. If you press enter, then it goes and displays the header again, and we go to our interface. Okay, so now if we go to step 3, it says step 3 will implement a user menu functionality. So that's this 1, 2, 3, 4. So press 1 to display the information of nodes, 2 to generate random values for all nodes, 3 sort specific node values, and 4 exit. And then you have a choice. Okay. So if we quickly go out, it's going, by using an appropriate repetition structure and a nested selection structure, user will be able to choose between the following. So appropriate repetition structure and a nested. Nested mean in this repetition structure, we need to use a selection structure. So I hope you are familiar already with a user interface functionality, how we can do that. Then if you go along, it's going to say the following functions must be implemented and called from the main function. Please refer to the function prototypes given in the template to better understand the parameters and return types for each function. Do not change the parameters of the return types. Functional functions should use this given program constants defined to get the repetition structure. A complete correct program should be able to adapt to the constants. Okay, so we've got program header, we've got program menu, display values, calculate average. Okay, so let's quickly, we're going to quickly go one by one. Program header, go and display the program header. Program menu, display the menu, and the menu is this 1, 2, 3, 4. Okay, display the values. That is then part of this display information of nodes. Okay, so it's going to display those node values for us. And then if we go along, it's going to say calculate average, generate random. So if we quickly jump into, before we go to calculate average, let's quickly just go to generate random. You will see here the function will receive an array to populate as a parameter, as well as two parameters called F and C. Okay, F and C, floor and ceiling. F corresponds to the node floor value given, and C corresponds to the node ceiling value. So now we can see, okay, the floor and the ceiling is the minimum and maximum value range, basically, for our random numbers that we need to go and generate. The node floor and node ceiling values indicate the range. Okay, cool. So now if we go along, there's just an example. So if the floor is 3 and the ceiling is 9, the random values must be between 3 and 9. Okay, and I said explicitly here that 3 is smaller than and equal to, and then value is smaller than and equal to 9. So it means it's, if I say node floor is 3, 3 is included, and if I say node ceiling 9, 9 is also included. Okay, so if we go further, it's going to say here bubble sort. This function is called at menu selection 3 in order to sort an array from low to high. Okay, an array meaning one array. The function will receive only one node values array from the main function. The user will select an appropriate TUT IoT node, and the function call will send the correct node value array to the function to be sorted. Okay, and just say run the showcase exe file and try to recreate it exactly as shown. And then it's also just, here's the flow format. First the libraries, then the structure, then the function prototypes, main functions, step 0, 1, 2, 3, and 4. Function definitions, this is the function definitions. Okay, so now if we quickly go back to our showcase file, now that we have entered sensor 1, sensor 2, and sensor 3 with its corresponding floor and ceiling values, now we can go and display something maybe. So if we press 1, it's going to say node 1. The name is S1, sensor 1. The range is between 1 and 4. The average is at the moment 0. And the values inside of this array is all zeros. So if you can remember in step 1, if we quickly go up, in step 1, it stated that, if we quickly jump to step 1, it stated create a dynamic array of size, node value size, provide a constant for each pointer called node values, and initialize each value of the array to 0. So we're going to quickly go and look at what's all this stuff here, and maybe it's going to make much more sense if we go to the template. But then we can see there's node 2, the name is sensor 2, and everything is still all zeros, and the average is also 0. So now it says press any key to continue. If I press any key, it's going to jump back. We can then press 2, generate random values for all nodes. If we press 2, it says random values generated for all nodes. If I go and redisplay maybe, it's going to show me still sensor 1, S1, S2, S3, so node 1, 2, and 3. The average have now changed because we've got a random generated values for each index of this values array. And you can see that the range is between 1 and 4, so all the values are going to be either 1, 2, 3, and 4. And that's going to be the same for 3 and 6. For S2, you will see there's random numbers between 3 and 6, and the same for S3 between 5 and 8. Now if I press any key again, now sort specific nodes. So if I press 3, I need to go and select a node. Okay, so let's go and maybe sort node 3. So now it's going to say node values sorted. So 3, you can either display 3 in there if you wanted to. I think there's just a mistake, but no big deal. That's just a display. But it says node values sorted. Now if I press any key to continue and I go and display, you will see we sorted node 3, and you will see that it's now sorted. So it's 5, 5, 5, 5, 5, 6, 7, 8, 8, 8. So it's sorted ascendingly. And then you can go and play along with this again. We can maybe go and sort again. We can sort node 1. And we can go and display, and you will see that node 1 is sorted. But remember, we didn't sort node 2 or S2. It's still as it was. And if we quickly go and say generate random values again, random values generated, and we press 1, you will see that there will be new random values given to each node, and they will be unsorted again. And then we can press 4 to exit, and it's going to say thank you for using TUT IoT, and then it ends. Okay, now let's jump into our code. So we've got our code open here, and we're going to quickly go and start solving this application. So you will see here student details complete. So please add your name and your surname there, add your student number there, so 1, 2, 3, 4, whatever. But before you do this, I would recommend that you first go and close this, go back here, and then make a duplicate of this template file, and the duplicate, go and save it as your student number so that you know where your code is and how to work from it. And then you can also keep the template file open for you to go and look at it if you have maybe deleted something. So I'm going to open my answer here, basically my program that I want to submit, and I'm also going to open the template file for reference. Okay, but we can go and close it if you would rather want to work only in one file at a time, but it doesn't really make a difference. So after, you can go and change your, let's go and say 1, 2, 3, 4, 5, 6, 7, 8, your student number, and then name and surname. I'm just going to write QWERTY for each, or QWERTY and QWERTY. And then we've got our C libraries there, do not change. This is the C libraries that you would need to use. We've got our constants, number, maybe change without disruption, do not change. So this is just, we can go and change the sizes here if you want to, and it's not going to affect our program. So we just need to make sure that we want to create our program in such a way that the program or the application is not disrupted if we make this application maybe bigger. And I will show you at the end what I mean with this. And then IoT node structure. This is your structure that was already defined. Structure member variables do not change. There's your structure member variables. You've got a char array for node name. You've got an int node floor, an int node ceiling, and an int node values. Okay, and it's already renamed to IoT node. And then you've got your function prototypes, do not change as well. There's program header, program menu, display values, generate average, generate random, bubble sort. You've got your main function. Sorry, let's use the arrows rather. We've got our main function, declare TUT IoT array, do not change. So this step was already completed for you. And then we've got our step 1, initialize the elements of node values array. Okay, so we've got step 2. So I just created some blocks for you to work in so that you can solve this systematically. And then you will see here function definitions, program definition, or function definitions for function 1, program header, etc. So let's go and start solving this evaluation 2. So the first thing that I'm going to do is I'm going to copy my function prototypes. I'm going to go all the way down here, and I'm going to quickly go and implement them. So I'm just copying them so that I don't make a copy or a retype or a typing mistake. So copy just works much easier. So I'm quickly copying each one of them in their correct sequence as well. So we've got our functions here. So program header. So I'm going to remove the semicolon and I'm going to add my brackets. So now I can quickly go and do that so that I don't have to go and do it again. So that's the easy, quick part of just getting my program ready for debugging and starting to solve each of the functions as well as the phases that was or the steps that were defined in the PDF. So there's all my functions implemented basically, so there's no code in them at the moment, but don't worry too much about that. So now we've got step 0 that's done. Now we need to start with step 1. So in step 1 it was asked that we need to go and use 2 for loops or repetition structure, so it wasn't defined, but a for loop is more or less our best option because we're working with arrays and we can use a counter-controlled for loop or counter-controlled repetition structure for us to go and create a repetition structure with a set amount of repetitions or loops. Okay, so I'm going to create a counter variable for my for loop. So the 4 golden rules for counter-controlled repetition structure is counter variable, initialize that counter variable. That counter variable needs to end somewhere, so a condition, and lastly we need to increment it or decrement it. It needs to change, otherwise it's going to be in an endless loop. So I'm going to initialize it to 0. The condition is going to be I is smaller than, and if we quickly jump back, see I closed it, oh no it's there. If you see here, create the dynamic array of size node value size, okay, for each pointer called node values. Okay, so let's quickly jump back. You would see inside of our IoT node there's a pointer called node values. So we're going to create an array for node values. So in order for us to go and create an array for node values, and if we quickly go down, you would see that we've got an array here of sensors or nodes basically. Now this is an array of type IoT node, so it's a structure. So TUT IoT is an array of type IoT node structure, and the size is IoT size. So we need to traverse through this array, and then for each element we're going to have a pointer called node values, and we need to go and create a dynamic array for that. So that's hence the 2 repetition structures. So first off, we will traverse through our array, and the size of that array is going to be IoT size, okay, as you declared it there, at the, or it was already declared for you. So we're going to traverse through it, and then for each of those indexes, okay, so TUT IoT, okay, so TUT IoT, that's the name of the array, TUT IoT, for each element. So we're going to put a bracket there, square brackets with I. So for each element of that array, we're going to generate for the node values pointer, we're going to generate a dynamic array. So dot, we're going to say dot node values, that's our pointer, and it's going to, we're going to use a calloc statement as defined in the PDF to go and create basically for us a dynamic array, and the dynamic array size was node values size. Okay, so oops, there's a typing mistake. So always nice if you know that you typed it correctly. If you press Control Spacebar, it's going to show you the name. So node values size, and then that's going to be the size of this dynamic array, and then lastly we're going to use size of, and that array is basically going to be an integer array. Okay, an integer array, so it's going to be size of int, semicolon. So now we've generated a dynamic array basically for each element of, or each index of this TUT array. But then the PDF stated that we need to go and initialize each of the indexes of this newly generated dynamic array. So I'm going to create another counter variable called j, and j is going to traverse through our new dynamic array. So it's going to be j is equal to 0, j is smaller than node values, okay, and then j plus plus, and then we're going to say TUT IoT, and then that's going to be our array, and the index is going to be node values. Okay, there's our node values dynamic array, and then for each index we're going to initialize it to 0. Okay, so if we quickly zoom in, just make it a little bit bigger. Okay, so now we have created our dynamic array, and we also initialize it, and that's all for step 1. That's everything that you need to do. Initialize the elements of node values array to 0. Okay, and then the other one was create a dynamic node values array and initialize. Okay, so we've done that. Now we're going to go to step 2, where we're going to go and populate node names, node floor and ceiling. Okay, so first of all, what we would need to go and do is go and display our program header. So program header, that's the function that we will go and call. So program header is going to display our basically our application header for us. So if we quickly go and do it, that's just a few nice printfs, and it doesn't really matter. You don't have to go and count exactly how many plus and minuses there was in the program header. It's just for display purposes. You can go and recreate it as close as possible, but you don't have to really go and count exactly how many spaces exactly I used in my showcase file. So I'm just going to say plus minus, and I'm just going to make it, oops, sorry, wrong button there. Let's quickly go up, all the way up. So I'm just going to go and make it more or less this size. It's going to be 1, 2, 3, 4 printf statements, and there we go. Then we just need to remember new line and a new line, and then we've got a oh, there is a extra printf. Okay, I was correct. It's going to be a straight line, and then down a plus, and then a straight line, and the first one is going to be welcome to TUT IoT. Okay, and we can go all the way up here, and we can add a plus sign there, and straight line and a new line, and then we go on, and we're going to say this is for engineering software design. Okay, and now you can see that, oh shucks, the spacing is not nice, so let's just add maybe an extra one there, and then we can add a plus and a new line, and now it's going to be our student number, and our student number is 1, 2, 3, 4, 5, 6, 7, 8, 9 for now, and we can go all the way up, straight line, new line, and you will see that we will just need to go and add just a few extra plus and minuses there, so that we have our program header. And that's it. That's our program header. So let's quickly go up. You will see there's our program header. Okay, and then let's quickly go and run it and just see how it should look like. Okay, so we have that more or less. Then populate the following. So we can quickly go and grab this maybe. I'm just going to copy and paste this. So copy. We can go and say, where is my copy now? Let's quickly check if it works. There we go. It's did copy. Okay. So this is what we need to go and display basically now to our user. Okay. So there's no function for this because it's only done once. So we don't necessarily actually want to go and create a function for this. So this is just going to be maybe a printf statement here inside my main function. And then inside my main function, I want to go and say populate the following. So a nice thing, if you did copy and paste this, we can just do the following. We can just put it there. And that's going to be populate the following. And we can just add a new line. And then again, we can go and use a printf statement. And I'm just going to add it there. Node value names, new line, semicolon. Again, a printf statement, and just remember your indentation to keep your program nice and neat. Semicolon, printf statement again, end it with a semicolon, and then press any key to continue, and semicolon. Okay, so I didn't give you the printouts of this, but you could just go and copy and paste it as you just saw very easily, so that you don't have to go and waste time to go and retype this word for word. Okay, so if you see my program, let's quickly close it again, and we're going to quickly run it. You will see populate the following: node names, node floor, node ceiling. Press any key to start. So it's like press any key to start and then it waits. And we know by now that when that happens, we use a get char function, and it's going to wait. Then after that, we need to go and maybe just to make it nice, we can just add 2 new lines maybe there, just to space it out nicely. And now we need to go and populate basically all our stuff. But before we do that, let's just save this, build and run, and see what happens if there's any mistakes. There's my header, populate the following node names. If I press enter, then I can start. We can see there, oh, node ceiling, I forgot a new line maybe there. Just add a new line, cool. Get char, oh, yeah, no, I didn't forget it there, sorry. It's there that I forget it actually. And I can save this. If I quickly run this, you will see that, oh, okay, it's now solved. Everything looks nice and neat, and my program is starting to shape. So now I need to go and enter basically everything into my array that was created already. So we can just go and reuse those variables that we've created. We've got I and J. We can also just go and take out this one here, and we can just go and place it there so that we can just go and reuse it if we need it. So we've got that counter variables already declared, so we can just go and say I is equal to 0, and then I is going to be smaller than IoT size, my constant, I++, so that's going to help me to traverse through this array. And then we need to go and basically grab for us the following. So we've got printf statement here, and what I'm going to do here is I'm going to quickly, just before I do this, I'm going to quickly run to my program, and I'm going to quickly copy and paste this here. So this part here, I'm going to quickly copy that, and I'm going to paste it there. Node name 1. Then I know there's going to be another printf statement after that, and in between there's going to be scanf statements. So what I'm going to do is, let's copy that. It's going to be node name, node floor, node ceiling, floor, ceiling, and then here we can just add a new line at the end, and you will see here that I'm going to quickly just copy that. We've got S1 maybe, then it's going to ask for node floor. I'm going to quickly copy that, paste it there, and then 1 and node ceiling. Okay, node ceiling, and that's going to be my output basically to my user. And then I know I need to use a scanf statement to go and populate this array and the values inside each index. So remember, the array is of size of the structure that was given, and there's variables inside each of them. So we're going to get the name basically from the user. So %s, that's our easy way to go and populate basically a char array. So TUT, we're going to have our square brackets because we're traversing through that array. So we're going to put I there, and then dot the node name. So that's where we're going to go and store this. Then next up, another scanf statement. And then inside this scanf statement, we're going to grab basically the ceiling, okay, of this array again. So that's going to be node, oh sorry, it's floor first, node floor. And then that's going to be very similar, but it's just going to be node ceiling. Okay, so now we've got node floor and node ceiling and the name that we've captured. And after that, after we've captured everything, S2, 1, 2, 12, S3, 1, 2, and you will see press any key to continue again. There's like a wait. So after we have captured everything with our for loop, we can go and just do a printf statement here again, printf statement, semicolon, and then get char, okay, so that it waits. And then after the user has pressed something, after we've pressed it, so you will see here, after you press any key to continue, what happens to the screen? It clears. So we know that we can use system CLS, and that was also given in the PDF. So we can go and use that. Oops, I think my debugger is now floating, so I'm just going to close it. So now if I run this, we're going to have node names, node floor, node ceiling, press any key to start. We can go and say S1, 1, 2. Oh, we can see that there's a mistake. So what's the mistake? Always if you see something like that, it's normally something with the scanf that's incorrect. So we know that when we scanf values %d, we need to have ampersand. So we just can't forget to use our ampersands. So if we run this again, let's quickly say press any key to continue. S1, 1, 2, S2, 1, 2, S3, 1 and 2, and you can see everything is working now. Now it ends there because we haven't done step 3 yet. So now we can see, okay, step 2 is now already working, and the only thing left is now step 3. So step 3 is basically to go and create our menu. So we will go and create a choice variable, and then what we can use is a do while statement, and then we can say program header again. We want to go and display program header, and then we can go and use choice, and we can set it equal to our program menu function. Okay, we haven't implemented the program menu function, but we will do it now shortly. So if we go to program menu, you'll see it's returning an int. So if I quickly jump back and I run my program, so remember this is the showcase, S12, 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 press any key to continue. You will see that's all the content that we need. 1, 2, 3, and 4. So I'm going to quickly copy and paste this, and I'm going to jump back to program menu. I'm going to paste it there, and then I'm going to use a printf statement. Okay, and I'm going to just do this, copy just this part of the printf statement, and then I can just go and paste this here. Okay, and then this part of the program, of the printf statement, I'm just going to paste at the end here. And then lastly, we just need to add new lines, new line there, a new line, and that's not going to receive a new line. The exit is going to receive a new line, but not the choice. And that's everything. So before I continue, do my indentation, make sure that my program is nice and neat and everything's indented as it should. Okay, and then we will use a scanf statement. Okay, so when we use a scanf statement, we need to go and create a variable. So we can just go and call it int c maybe, and then we can just go and say scanf. Okay, scanf statement. We're going to grab a choice from the user, and we're going to put it into C, and then this function is going to return C for us, basically there. Just need to add that semicolon there, and now we've got our program menu. Hopefully everything is sorted and everything works. Okay. You can also, just for styling purposes, you can add another printf statement maybe here. But not a big thing. So we've got basically a C, and we are returning the C. And now we can go up to where we are at step 3. So we've got a choice, and then we know that we can go and use either a switch statement or an if statement. So we can go and say choice, and I'm just going to go and create basically the cases for each of them. Okay, and let's quickly just go and add the break statements as well. So I'm just going to copy and paste this up to that point there, and paste and paste, and then that's going to be 1, 2, 3, and then lastly we've got a 4 as well. So 1, 2, 3, and 4. What we can go and do at 4, because that's our exit, we don't have to really do a break statement. We can do a return statement if you want to. Okay, to end your program at that point. So we can go and do a endless do while if you would like it. And then lastly, what's always nice to do is doing a default statement for invalid input. So we can just go and say printf statement, and we can say invalid input, please try again, you did something wrong in the selection. Okay, and that would need a break statement. Okay, and then after that, we've got basically our do while ready. We just need to go and complete our do while here, and as I said, I can just do an endless do while statement, so while 1, because when it hits case 4, we're going to return, and that's going to stop the main function completely. So we've got everything set up at that point. Lastly, we can just go and say printf statement here, and if you can remember correctly, if I can remember correctly, it was something like, thank you for using DUT IoT ... something like that, and then you can just go and add maybe a get char just to wait before it goes completely out. So that's going to be our exit for our exit, case 4. So if we quickly open it here, you'll see that's exit. And then we know that we need to go and do now each of those selections, case 1, case 2, and case 3. So first up, let's quickly just save this, and we know that everything we have now created. We haven't done all these other functions, but we've got program menu and program header. So let's quickly build and run and see what will happen. So we've got S12, S12, S12. This is just demo input. Press any key to continue. Now it jumps to our welcome to TVT IoT. And now I can press 1 and it's going to redisplay it. Press 2, it's redisplay. 3, 4, it's going to exit. And now we know that we just need to go and clear our screen, okay, after each of these selections. So what we can go and do is we can just go and add a printf statement, and we can go and say press, and we can just go and add a new line maybe, press any key to repeat menu, menu, and then we can just go and add, we can just go and add a get charge statement for each, and that's going to be a get charge statement to wait, and then after that we can do a system.cls. And that's basically it for this part. And then we've got S1, 1, 2, S2, 1, 2, S3, 1 and 2. Press any key to continue. This jumps to the main menu. Press 1, go back, 2, go back, 3, go back, 4, exit, thank you, and we're done. So now everything is repeating as it should, everything is working as it should, and now we can go and start implementing our functions. So let's first go and implement the functions before we go and call them. So display values is receiving an int array. So int array, if we just want to go and display an int array, so it's going to be rather easy just to display an int array. We're going to just say printf, and we can just go and display the values. If you look at the output of your showcase, and that's going to be a for loop, and we can go and just create a counter variable there, int I, and we can just say int I is equal to 0, and then I is smaller than, and you will see inside this parameter list there's no size because we've got a constant that's overarching, so we can just go and use that node values size, so that's the array that we want to go and display with that if you read the PDF, and then I plus plus, and then we will just go and say printf statement, and we can go and say, look, I'm going to display %d, and I'm going to end it off there in between the semicolon, and what I'm going to display is basically array I. And then we've got a printf statement, and inside this printf statement I'm just going to add a new line, and that's all that we need to go and do with display values. Now we can go and do quickly generate random as well. Not generate random, sorry. This is display values, generate the average, sorry, not generate random, generate the average. And the average is going to be very, very similar. So what we can go and do is, if you are familiar and you know how to do the average, you can just go and copy and paste that, and we know that we need to have an average value, and we're going to just make it of type float so that we don't have to go and worry about anything. So we're going to have a average there, and then inside we're going to traverse through each element. Oh, I see I had an int I there. Yeah, you can have the int I there. I see the compilers actually allow it, so let's quickly just go and remove that there. You can go and create your for loops as such as well. The previous all the compilers did give us some problems with that, but you can go and do it that in this way as well. So if you have a generate average, we create a float average value. We're not going to display anything. We're going to go and generate the average. So we're just going to say AVG for that average, and we're going to say is equal to AVG plus the array I. Okay, so you could also do this by just saying AVG plus equal to array I. That's also an option. It's doing the exact same thing. And then after that, we need to go and return this average basically back, and we can just go and say average is going to be returned, but we first need to go and calculate average, because average at this point is actually just the sum. So what we would need to do is we need to go and divide it by the node values size. Node values size, semicolon, and that's going to generate basically the average for us. Okay, then we are only left with function 5 and 6, but let's go and quickly first go and implement this. Okay, so inside case 1, we would go and then display the following. So let's quickly go and see what we will display. So if we display, it's going to say node 1, name, the range, the average, and the values. So what we can go and do is we can go and copy and paste that again. So I'm just going to make a nice little space here for me to work with. So I'm just going to put it there. So first off, before we go and display something, we know that we've got an array. Okay, so that means we need to have a for loop. So we can go and create a for loop. We can also go and create the counter variable in there if you would like to, but we already have that counter variable, but no big problem. It's maybe going to give us an error if we go up here, because it's already created there. So it's going to be maybe a clash. So just to show you, we can go and do that, and we can go and delete that part there, and we can just go and do it inline if you would like to. It's your preference, your style, but then you just need to remember to go and recreate that every time for each for loop. Otherwise you're going to run into a problem. So there's that for loop's done, that for loop and that for loop, so we are good to go. So now inside this, int I is smaller than, and that's going to be the IoT size. That's going to be the array size of the structure array, and then I++, so that we can go and traverse through it, and then we're going to go and display basically this now. So the first thing that we need to go and do is create a printf statement, and what we can do is, I would recommend this, we can go and quickly see one line we're going to print out, maybe print out the name, then print out the range. So 1, 2, 3, 4, and this is a function call. So we're going to have maybe, we're going to have 4 printf statements, maybe then a function call, and then just a new line just to make space, a space between each. So the first thing that we would like to go and display is the node there, and then what we can go and do here is we can say %d and square bracket. So that's the first thing that we want to go and display. So that's going to be add a new line, and then what we want to go and display is basically the it's fine, that's going to be the node, just the node number, Then we want to go and display the name, so we can go and copy the name. Then we want to go and display the range, so there's going to be a %s and then a semicolon. And then we want to go and display the floor and the ceiling. So the floor and the ceiling, as you can see it here. And then we can just close that curly bracket, semicolon, just for styling. We're going to display the average. And then after the average, we're going to display basically a float. And if you go and look here, it's 3 values after the comma. So that's 0.3 and then a new line. So we've got node, name, the range and the average. And then we can go and do this spot here. That's going to be our display function that we've implemented. So now we can go and call that nice function that we created, and it's going to be display values. Display values all the way up here. We can go and call display values. Display values are going to also receive something. So let's go and start populating this printfs to make sure that we display everything. So we've got name that we want to go and display. So that's going to be TUT IoT square brackets I, because you're traversing through that array, dot node name. Okay, so that's the first one. Then we can go one further and we can go and do the range. That's going to be node ceiling, and there's 2 of them that we're displaying there. The first one, not ceiling. The first one is going to be node floor, and then we're going to do node ceiling, and that's going to be for the first percentage and the second percentage. And then we want to go and display the average, and the average is going to be inside a function. So we need to go and calculate that basically for us. So we can go and say call that function generate average, and we can do it inline if you'd like to. And we can say, what do we want to send it? We want to send it the array, okay, the array of TUT IoT, and that's going to be our dynamic array. So we're going to send that. So it's going to be TUT IoT, and that's going to be the node values array, that dynamic array that we've created. So basically, if you would see, this is a function call. It's going to send back the average, and we can do that. We can call display values that will display all the values, and then we're done. And then hopefully after that, if you just want to go and do your indentation nice and neat, if you would, then it's all in line, and then we've got basically all that done. Now we can go and build and run. Quickly go and check all our errors, make sure. You can see there's still an error there, node values, we didn't send it the array, so we can go and send it the array as well, and then we can save node values, we can build and run. So let's quickly go and run our program. S12, 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 so it's just dummy data, display the information, nothing happened. Okay, so display information of nodes, nothing happened. So we've got a little bit of a problem. So we need to go and double check what's wrong here. So we need to go and search for our mistake. So nothing happened at case 1. So we need to go and check what actually happened here. Is there maybe a problem here? So let's quickly go and double check. So in the program menu, we are calling in program menu, displaying the menu, sending something back, return C, and we are grabbing it at choice, so it should go into this point here. So let's quickly go, let's just close that one there, let's quickly build and run, let's quickly go and see how we would sort this out. So I'm just going to give it demo, dummy data. Okay, press any key to continue. So 1 is not displaying anything. Okay, so why? So let's quickly go and check. For int I is smaller than IoT size. So it's not running into this here. So now we can wonder, what is the problem? And that's the golden rules for counter-controlled repetition. So we didn't initialize. Okay, so you can go and solve your errors like that. It's sometimes tricky, but that's just the basics. So we can go and say S1, 1, 2, S2, 1, 2, S3, 1, 2. Press any key to continue, press 1. And as you can see here, it displays all the information for us here. Oops, all the way here. So node 1, 2, 3, averages, and everything is done. Okay, so now lastly, that's everything that's left is going to quickly go and generate random it's the generate random function, generating random function. That will enable us to go and create random values, and we can go and also do the sort. So the bubble sort and the generate random values are basically, we can just go and call the srand function to randomize this by using time, and we can say time null. So that's going to randomize this. We can do it with a counter-controlled for loop. Int I is equal to 0, don't remember, or just remember to initialize it. I is smaller than node values size minus, not minus 1, sorry, just node value size. I'm thinking about the bubble sort now. So array I, and we can just go and do a random there. That's going to create a random value for us. Now we just need to ensure that it's going to be inside the range of F and C. So how you would do that is basically using the modulus. Okay, so we can do C is the ceiling, minus the floor plus 1, and then we just add F, the floor. So that will give us a random value in that specific range. Generate random values, bubble sort, we can do the bubble sort as well. It's going to be 2 for loops like this, and then another for loop, but we're just going to make it J. Okay, so we've got 2 for loops, and we can just minus 1 at that point there, and a minus 1 there as well. And then we can just quickly correct our indentation, and then we can do an if statement, and we can say if array j is bigger than array j plus 1, then we just go and do a swap algorithm. Okay, the swap, and the swap is going to be basically hold is equal to array j, and then we can have array j is equal to array j plus 1, and then array j plus 1 is equal to hold. So that will then effectively turn everything around or swap them around. Just need to remember to go and actually create a hold variable as well, and that is the bubble sort. So after that, we need to go and then actually go and implement them at case 2 and case 3. So case 2 is basically going to be a traversal through everything again. So we're going to say a for loop, because we want to go and traverse through each element and generate a random value for each. So that's going to be basically what will happen at that point, and that's going to be generate random. Okay, now generate random has what's all the parameters. So let's quickly go and look. Generate random is going to have an array, the floor, and the ceiling. So if we go all the way down again, it's going to be the array. So TUT IoT brackets I, and that's going to be the node values array that we're going to send it. Okay, and then it's going to be a comma because that now it's our second parameter. So our second parameter is going to be the node, the first one is the node floor, okay, comma, and then the node ceiling, and then semicolon. So that's going to be our call, and then we just give the user some nice little feedback with a printf statement, and then we can say random values generated for all nodes, okay, and then new line, and then yeah, that's basically everything that we need to go and do. We just need to have that printf statement not inside the for loop, sorry, it's going to be outside, and technically if it's just one line of code inside our for loop, we don't need to have have the brackets there, so that's quite nice. Then that's going to generate our random values, and we're going to double check it now in a moment. Okay, let's just add a space there to make everything nice and consistent. Now you can see exactly what's going on here. Okay, you can do that as well if you want to make everything nice and consistent to what we are doing. Then lastly, case 3 is going to be a printf statement. And now if we quickly go to the demo program, quickly again, just for the last time. Oh, don't open it with Visual Studio. Wrong button. Sorry everyone. So if I quickly go and run the showcase file, okay, it's going to, we're going to quickly just add that demo data. And then if we press 3, it's going to say select nodes that we want to sort. So choose between 1 and 3. Okay, so now I'm going to quickly I copied that, and that's going to be for the sort. To select the node, sorry, yes. Now I just need to paste it there. Select a node to sort. So the first step would be to do a printf statement. So we're going to say basically select a node to sort and %d, and then it's going to be a semicolon, %d, and then we go and put in the basically the first one, that's going to be a 1, and then we can do also just IoT size if you would, IoT size, okay, and just to make our program robust to any changes. Okay, so 1 to IoT size, and then we can do a scanf statement just to go and basically grab something from the screen. So we can use a scanf statement, and we can just go and create maybe a character there. We can call it char select maybe, or we don't have to create the char, we can just create the integer, sorry, and then we can go and put that inside select semicolon, and then we can just say if, just to make our program also maybe a little bit more robust, if choice is bigger than and equal to 0, well, technically it's not bigger than and equal to 0. We can just go and say bigger than and equal to 1. bigger than and equal to 1, and we can go and say if choice is smaller than and equal to IoT size. Okay, if that's the case, it's inside the correct range that we now just gave to the or showed the user here. So now we know if that is correct. Okay, if that is correct, we can go and bubble sort. Else we can just also give maybe some feedback to the user and say, listen here, you made a mistake. Another invalid input maybe here. And now after that, what we can go and do is we can do a bubble sort. And inside this bubble sort, we will send basically the node values array to it. Okay, but what node values array? Not I. We're going to send the user selection one. Now, the user is going to select, if you remember here, 1 to 3. Because we're working with 1 to 3, but our arrays are not working with 1 to 3, so we will say select -1. Okay, select -1, just make sure the spelling is correct. Select -1 and the node values. So we're going to sort this. And then lastly, we can just go and give another little bit of feedback. And we can say node, and that's the mistake inside my program or the simulation. We could actually go and add that there, a %D, and we can say the node values sorted. Okay, dot, new line, and we can go and say select. And now we're going to display select there. So it's going to be sorted. Great stuff. Okay, and that's basically the memo. Let's see if there's any other mistakes. Printf statement. Oh, this printf statement has nothing in there because that's just something that we don't need. Let's quickly build and run, and let's see if our program is working as it should. So let's quickly try it a bit bigger there. I'm just going to make the text a little bit smaller so that we can see everything nice and clear on our program. So as you can see, this is my memo that we've now just completed. So S1, we're going to give it a range of 1 and 4, 1 and 4, S2, 2 and 5, S3, 3 and 6. Okay, press any key to continue. Done. We can go and display it. Node 1, 2 and 3, everything is empty. S1, S2, S3, the range 1, 4, 2, 5, 3, 6. Yes, the averages are 0, and then the values are all 0, so that's correct. We can go and generate random values generated. We can press 1 and see. Node name is 1, 1, 4. The average is 2.2. So 1, 2, 3, 3, 3, 3, 2, 1, 3, 1. So that's inside the range of 1 and 4. We'll see that's also in the range of 2 and 5, inside the range of 3 and 6. And we've got our averages. You can go and double check that your averages were calculated correctly. And then if we display it again, you will see, let's go and sort this node 1. So if I press 3, it's going to say node 1, node values sorted. So let's go and display that. 1, 1, 1, 2, 2, 3, 3, 3, 3, 3. So now we can see that everything is sorted ascendingly. And then just as a last double check, generate random numbers again. You will see there's new random numbers and it's not sorted. Okay. Now, just as a last little bit, I said I will go back to this. What you can go and do is you can go and change maybe this to 4, define IoT size to 4. So there's going to be 4 sensors maybe. We can make the array maybe node name. Oh no, that's the node name. We can just keep it that as is. We can go and say node values 5. So there's only going to be 5 values. And if we run this, our program should still work as it's supposed to. So now, if I run this, it's going to be S1, 1 and 4, S2, 2 and 5, S3, 3 and 6. Now you see, node name, we can have S4, and that's going to be a 4 and a 6, and then it's done. So now there's 4 sensors, and now if I display this, it's going to display 4 sensors. It's going to generate random numbers for 4 sensors, and everything works as it should. I just saw there's maybe one small little mistake in my display. There, node name, that's not, we can go and change that maybe, and not say node 1 the whole time. You can see there, I just made maybe a mistake there. It's still saying node 1. So we can quickly go up and we can go and fix that maybe. That's going to be in here. After this part here, node name 1, we can just go and say %d, and we can go and say I plus 1. We can just go and display that as I plus 1, keeping it to 4 and just 5 values. So if we can quickly go and upgrade this. Let's go and make it 5 sensors. Okay, if I run this, press any key to continue, it's going to say node name 1. So S1, 1. Sorry, let's just rerun that, just a typing error. S1, 1, 1, S2, 1, 1, S3. So now you can see that it's saying node name 1, node name 2, node name 3, S3, 1, 1, node name 4 is S4, 1, 1, S5, 1, 1, and then press any key to continue. There's just a node name floor 1, node ceiling 1 that we also need to go and change. But if we just go and display this, it's going to display now again for us 5 sensors. So last little thing that we can go and just correct, I forgot to correct it actually at all the places. So just that %d part there, we can go and fix that. And now everything should run. So if I press it again, node name 1, 1, 1, 2, 2, 2. So everything is displaying 1, 1, 1. We can call this sensor 3 and give it some other values. Okay, so 3, 3, 3. So that is basically the memo. I hope you guys have followed along. Make sure that you understand this. Very important to understand what's the array, what's not the array, how to work with the elements inside the array because it's an array of structures, and how to work systematically to solve the memo basically. So work through this, make sure that you understand this. This is really, really important, especially for this second semester where we work with, we're going to start working with objects later on in the second semester. In objects classes, we work with this type of thing all the time, and specifically when we work with, for instance, TUT, IoT, brackets I, node values, working with an array of structures. That's very important, working with the elements in the structure and then sending that to functions. But that's it. Thanks, ladies and gentlemen. Keep well, and good luck with the rest of the semester.